Hi, I'm Colm Harte. I'm a technical director at NearForm, and I'm going to be talking about building a COVID-19 contact tracing app with a focus on open source and a decentralized approach. So our journey in relation to building contact tracing apps began back in March. It was at that time in March that the news cycle was becoming a lot more frequent in relation to COVID-19. People are becoming very familiar with the headline stats in relation to COVID-19. And we received a call from the HSE, which is the Irish Health Authority, on Saturday, the 22nd of March, asking if we could help build a digital contact tracing solution. And they had one high-level requirement. We need to be able to detect when people were too close for too long, which sounds pretty straightforward, but actually it's quite difficult to implement in practice. So the things we had to consider is, how do we actually achieve this? Obviously, you're going to need some hardware to do the actual detection piece. So we looked at what people already have in terms of devices that could do this. And the smartphone was your obvious answer. And then you would look at the capabilities on a smartphone to see what you could use on a smartphone to do that type of detection. And I guess there was a few different options you could consider. So for example, you could try and do it with GPS. Bluetooth was an option. You could also look at using ultrasonics. With GPS, you have a lot of challenges. Probably the real challenge there is just from a privacy perspective, because you would now effectively be tracking everybody at all times. And obviously that's quite invasive from a privacy perspective. You have a similar challenge with ultrasonics in that the user has to keep their microphone on all the time, which again would be discouraging for a lot of people. So Bluetooth seemed like the best option. And at the time, there was other people also starting to roll out contact tracing solutions. So Singapore had just gone live with theirs, and they were using Bluetooth to do proximity detection. So we kicked off an initial engagement with the HSE. They asked us if we could turn around a prototype within 5 days. So by the Monday morning, we had designs developed that had the end-to-end flow of the application in place. And then we kicked off the development side of things. And we broke the development team down into 3 focuses. So you had the front-end team building the mobile application itself. We had a team focused on developing using Bluetooth to do that proximity detection. And then we had our back-end team that was setting up the infrastructure and setting up the back-end services. And then within 3 days, we had a prototype of the application itself running on phones, talking to a back-end. Infrastructure stood up in AWS. Now, this wasn't doing the proximity detection piece. We had a bare bones prototype of that working, but that was a piece that was going to prove the most challenging going forward. So there's an awful lot of challenges in relation to trying to get Bluetooth working reliably on devices. The main challenge is particularly in relation to iOS devices. So on iOS, as soon as the app goes into the background or you lock your phone, effectively Bluetooth stops working as we would need it to work to do proximity detection. We had seen the same problem with the Singapore app, and the Singapore team had the same issues. Other countries are also trying to solve this particular problem. The HSE were able to set us up with a contact in Apple. We had some calls, we went through what we were doing. But the ultimate outcome of that is there was no easy way to get Bluetooth working reliably on an iOS device. The operating system itself just wasn't designed to allow it to do that for privacy reasons. So that was quite a challenge to the rollout of the application itself. We had everything else in place. We had the full end-to-end application working. We had the back-end stood up. But we had this one fundamental problem. If we can't get it to reliably work on iOS devices for proximity detection, is it really a solution you can roll out to the general population? And the answer to that really did come back with, no, this is just not going to be good enough. Now, at the same time, Apple and Google then announced that they were going to deploy the exposure notification service, which solved the problem of Bluetooth on devices. So they kicked off that initiative towards the end of April, and we were working with them as part of the early beta program. And that was quite challenging itself, because as they were actually developing the APIs, we were trying to build an application on top of them. So they would often make changes that would break the API, and then we'd have to rebuild the application. But we were happy to do so on the basis that we knew this would be a better solution in terms of how we move forward. The other key thing as well in relation to the exposure notification service is that it was a decentralized model, right? So the initial approach we had taken was a centralized approach. And what that really means is that the device itself was doing the proximity detection, and we were actually storing the proximity events on the device itself. But when someone would test positive for COVID-19, we'd ask them to upload their data. The data we'd send to the server would be your information plus all the people you had contact with. And then the server would be able to reach out to those people and let them know they'd had a close contact event. The decentralized model is a little bit different. The way that one works in particular is all the data stays on your phone all the time. When somebody tests positive and they're asked to upload their keys, what they send to the backend server is their identifiers only, not all the identifiers of anyone else their phone has detected. And then periodically what's happening is the other phones are pulling down those identifiers, looking through their history of identifiers they've recorded over the last 14 days. And if they find a match, they will then alert that user that they've had a close contact event with someone that tested positive for COVID-19. So this approach is great from a privacy perspective. All the data stays in the user's phone. There is no central server that has all this information stored on it. It does provide some different challenges. So from an epidemiological perspective, they're getting less information in terms of what they would like to see. So for example, they can no longer identify the super spreaders because they don't know who has had contact with who. So even though we know who uploads, we don't know which people receive alerts specifically because of that person that uploaded. But I think what was really important was just that whole decentralized approach was much better just from a privacy perspective, and especially when it came to the public and the general population, the media, understanding how these applications would work. Because there had been a lot of concerns in the media around, will this be effective? Will it work? And how is it going to manage my privacy? Is it going to be tracking everything about me? Is it going to know my location? So the combination of Bluetooth and the decentralized approach really helped to answer a lot of those questions. And then the other key piece that really made a difference from a privacy and transparency perspective was the fact that all the source code for the COVID-19 application was open sourced. So it was initially open sourced at the end of development on the Irish app. And then shortly afterwards, the Irish government actually donated the code to the Linux Foundation. So it now sits in the Linux Foundation on under a project called COVID Green, which is within the public health initiative within the Linux Foundation. And in there is the full stack that was used for the contact tracing application. That includes both the UI app itself, the backend services, the infrastructure, everything it takes to stand up a complete solution. And the reason that was important from a privacy perspective is that it now allows people to go in, look at all the code, understand how it works, understand how data is being handled, how data is being transferred, etc. And they can reassure themselves that it's doing what it should do based on how we said it works. And a lot of people actually went through that in quite fine detail to sort of validate the approach, validate the logic, validate the implementation. We had different universities involved that did reviews. So I know, for example, Science Foundation Ireland went through the code base. We had the University of Belfast. We had University of Pennsylvania, MIT laboratories. We had quite a lot of other groups that went through in a lot of detail to understand exactly how this system is working. And all these things are really important when you're trying to roll out one of these applications to the general population. So you really want to get widespread adoption for this type of application. We didn't have specific targets when we launched the Irish application, but within the first 36 hours, 25% of the population had downloaded the app. So, that was a great start to the rollout in Ireland. And I do think one of the reasons that was so successful was the fact that we had addressed the privacy concerns. The source code had been open sourced by the Irish government. Media had seen the fact it was open source. They'd also open sourced a lot of the DPIA and the DPIN information. So there was a lot of information put into the public domain about exactly how this application would work. So that gave people reassurance that they could trust that this application was doing what it should do, and that it really is just an additional tool in helping prevent the spread of COVID-19. And that's also a key piece. This is very much about augmenting the manual contact tracing process. All these tools and solutions are part of an overall approach to help COVID-19. And it's really about helping individuals empower themselves to be part of that overall solution. So I'd like to conclude there. Thank you very much for listening, and I hope you enjoy the rest of the conference.